In this video, we'll compare array with linked list. Basically, these are two physical data structures. In the beginning videos, I have explained that there are two physical data structures, or we can use combination of these two data structures. So basically, two physical data structures, array and linked list. So using these data structure, we implement other logical data structures. So let us compare them. First thing, where they are created in the main memory. Array can be created inside stack as well as it can be created in heap. Linked list, it is always created in heap. There is no meaning of creating it inside stack. Next, let us compare their sizes. This size is fixed. Once you created an array, you cannot increase or decrease the size of same array. You have to create another array. Next, linked list is in variable size. You can grow as much as you want. As much as heap memory is available, it can grow. When heap is full, then you cannot grow further. So this is fixed length and this is variable length. Next, advantage and disadvantage based on length. This is in fixed size. So the chances of getting perfectly utilized is less. Either it may be having some spaces left over, or it may not be sufficient for storing all the elements. So this should be used when you are sure that you will not get the number of elements more than this size. So if you know the maximum size, then create an array. It may be wasting spaces if you are not storing it fully. But linked list, when you don't know what is the length, you can go on creating nodes and go on adding it, and also you can go on reducing it. So when you're not sure how many elements, the list size, what is the size, then you can go for linked list. Then about space consumed. See, this will occupy space only equal to the size of the data. Suppose these are integers. This is the space for an integer, But here, this is the space for an integer. This is a space for pointer to the next node. Space for integer, pointer to next port. So inside every node for every data, there is an extra space required for storing the link of next one. So linked list takes extra space. Next, accessibility. This can be accessed randomly. Suppose I want to access something here. I can say A of 6 and I can access it. I can say A of 3, I can reach here. A of 9, I can reach here. But this can be accessed sequentially. If I have to access something here, then I should start from first and go on moving and reach here. If I have to access something here, then I should start from first and go on moving and reach here. Next, faster access. Who is a faster access? This is inside the stack, it is faster. Inside heap, two-step access, indirect access. This is always inside heap, so this is always indirect access. And also, this is random and this is sequential. We already discussed that. Now next, insert and delete operation. So for that, I will fill up few elements and then we will discuss about it. Let us talk about insert. If I am inserting any element here, at this side. So I should say inserting from right hand side. So it takes constant time. Just I have to write on the element. If I want to insert any element here, then I have to shift all the elements. So it means, let us say we are inserting from left hand side, from this side. So for shifting elements, it takes time. So it's order of n. So inserting that side is 1 and inserting this side is n, right? So this is minimum to maximum. If you insert here, it's n. So a little less than n, but still we say n only, right? But here means always constant. Let us see here. Let us look at the linked list. Inside linked list, if I want to insert here, just create a node, link it and move first. So this is constant. If I am inserting on the left hand side. If I want to insert something here, then I should move pointer P and bring it on some node, then I can insert a new node. So if I am inserting from that side, so let us say right hand side, then the time is order of n. Here it is 1, there it is n. Because I have to traverse through this linked list, then I can insert it. Here I have to shift the elements, then I can insert an element. So that side 1, this side n. But here this side 1, that side n. So if I talk about who is which, if I say insert operation is efficient on which data structure, so it is same. In array, shifting of elements. But in linked list, movement of pointer. So the time this side is 1, there it is n. There also we have 1 on that side, n on this side. Now it depends from which side you want to insert always. If you are inserting always from right hand side, then array will be faster. If you are inserting always on left hand side, then linked list will be faster. But one more important criteria. See, there is no shifting of data involved here. Shifting of data is involved here. You have to shift the data. So my data is integer. So 2 bytes, if I am assuming that integer is taking 2 bytes, right? So 2 bytes. If it is a double, then 8 bytes. If it is a student record of 200 bytes, then 200 bytes. So this is costly. Movement of data is costly. Here there is no movement of data. Then when it comes to data movement, this is better than that one. Because of shifting of the data, the time is more there, and otherwise they are equally efficient, only the sides are different. Now let us see delete. If I am deleting something from this side, delete 2, only the length of the list will be reduced, length of an array will be reduced. So it is order of 1. If I am deleting 8, then I should shift all the elements this side. So again, it is order of n. So deleting from this side is order of n. So insertion or deletion both takes order of n time here, and insertion deletion both takes order of 1 time here. Then come to the linked list. Deleting this node. Deleting first node, constant time. So same time, I don't write it again. Then if I want to delete this one, so first of all I should reach this node, then I can delete this one and modify this link to null. So if I am deleting this, then it is order of n. So it means if I am deleting from that side, then it's order of n. From this side, it's order of 1. So as far as I am going, the time will be more. Okay. Here, as far as I am going from in this direction, the time is more. If I am going that direction, time is less. Here, that direction is more. This direction, it is becoming less. So only the direction is different. Otherwise, the time taken for deletion is same. Both are equally efficient if data is not an issue. If data is larger, then here shifting of elements will take a lot of time, and there is no shifting involved here. So this is better in terms of data movement. The next, searching. See, upon array, we can perform linear search as well as binary search. This takes n and this takes log n. But in linked list, we can perform just linear search, which takes order of n. We cannot perform binary search. If we perform, then it will be taking n log n time. So we say binary search will be inefficient upon linked list. Reason, binary search means the elements must be sorted and we should go in the middle of a list. We know it well, right? We should go in the middle of a list. So when you are going in the middle of a list here, directly you can go. If I want to go into the middle of this list, so 0 plus 5 by 2, that is 2.5, floor value is 2. So I can go on to index 2 directly. But here going in the middle means I should scan through all the nodes and go in the middle. So this movement needs n time. Here it is faster because directly we can go in the middle. So always in the middle means log n time. So here also we will go always in the middle, log n time. But to reach middle, we have to start from first. So it's n. So it will not be log n, it will be n log n. So we say binary search we can perform. But binary search is famous for its log n time. But it will be more than that. So we say we can't perform binary search. We did not learn anything about sorting, but one thing I want to tell you, most of the sorting methods are designed for array. Some of the sorting methods are designed for linked list. So sorts, insertion sort and merge sort, they are designed for linked list. They are more friendly to the linked list. They are suitable for linked list. So we have this topic. We will learn about this one. That time I'll explain you how insertion sort is friendly with the linked list. They are suitable for linked list. We will see that later. So that's all. I have compared array versus linked list. Now who is the winner here? Depends on the requirement. depends on the requirement, right? If a space is the issue, this is better. Faster access, this is better. Variable length, this is better. Fixed length, this is better. Data is large, we don't want to move, this is better. We are always inserting from left side, this is better. Inserting always from right side, this is better. There are many things that decides, so you have to select the data structure carefully depending on your requirement, right? So study how you are going to use the data structure in your application. Depending on that, you select the suitable one. So I have compared them on various criteria that will help you to decide which data structure to use. So that's all about comparison of arrays and linked list.